Now let's talk about the first law of thermodynamics. Okay. Uh, the first law of thermodynamics says every system has a property called internal energy. It has a state function. Okay. What did we say a state function was? It's a property of a system that is well defined at equilibrium. And we say every system has what we would call internal energy. And this internal energy changes when the system undergoes a change. Okay. And so we represent that change by delta E. Okay? And what we're saying is the first law says delta E is equal to Q plus W. What that means is this. If a system undergoes a change, okay, from one equilibrium state to another, then if you add up all the Q's and the W's that are involved during that change, that will give you the change in the internal energy. That will give you delta E. So if you want to know what the change in the internal energy is, just look at how you got from your initial state to your final state, calculate all the Q's, calculate all the W's, add them all up, you get your delta E. Okay? So Q is the energy transferred due to heat, okay, and W is the energy transferred due to work. So that's the first law of thermodynamics. What it's saying really is this. Because it's a state function, it doesn't really matter how you get from your initial state to your final state. Remember we said heat and work are path functions? They depend on how you get from your initial state to your final state. So it matters. Okay? Heat would be different depending on, you get different values of heat depending on how you got from your initial state to your final state. Work varies according to how you get from your initial state to your final state. But if you're looking at the same initial state and your final state, even though you have different ways of getting there, if you add up all the Q's and the W's, you'll end up with the same answer. Okay? Q and W depend on how you get there. But if you add up Q and W, it doesn't matter how you get there. Okay? So that suggests then that Q and W must represent a change in some state function, a change in some property of the system, and we call that property of the system internal energy, because we've already associated the idea of energy for heat and work anyway, right? So the first law can also be stated as simply the law of conservation of energy. It's really nothing more than saying that energy of the universe is constant, okay? It's a law of conservation of energy because by definition, how did we define heat and work? Heat and work we define as just energy, that's something that's transferred from surroundings to system. So what we're really saying is energy is just being transferred in the universe from one place to another. It doesn't, you don't, it doesn't, you don't destroy it, you don't make it, you just transfer it from one place to another. Okay? So energy is neither created nor destroyed. How do we know this is true? Well, all our attempts to produce energy out of nothing have failed. Okay, so that is and it's because that is an assumption that would be consistent with everything else. So that's the law of conservation of energy. So the first law can also be stated by saying that the total energy of an isolated system is constant. What's a system that's isolated? One that doesn't interact with the surroundings. So Q is 0, W is 0. Okay. Anything could be happening within your system. Okay. But if it doesn't interact with your surroundings, Q is 0, W is 0, its total energy would be 0. Will not change. So delta E will be 0. So you say the total internal energy is constant. Okay? Since the universe, you can think of the universe as everything, right? We can think of the universe then as an isolated system. Then you can also state the first law by saying the energy of the universe is constant. Okay? You don't create or destroy energy, you just transfer it from one place in the universe to another. Okay. Sign conventions for delta E follow the sign conventions for Q and W. So remember we said Q and W are positive if energy flows into the system. Otherwise, it's negative. So delta E is the same thing. Okay, it's positive if there's a net increase in the energy of the system. Then you would expect delta E to be positive. If there's a net decrease in the energy of the system, you expect delta E, the final E, to be less than the initial. So delta E in that case would be negative. Okay, let's do a few concept tests here. Let's see if you got the concept. A system absorbs 10 joules of energy. What's delta E? Okay, there's no clicker here. This is going to be plus 10.0 joules, right? What's the delta E for the surroundings? If 10 joules went into the system, where did it come from? So what happened to the surroundings? It lost 10 joules. So delta E for the surroundings is negative 10.0 joules. What's delta E for the universe? It's always going to be 0, right? The energy of the universe is constant. Okay? So how about this one? A cyclic process. Okay, we say a system undergoes a cyclic process. If it goes through a series of processes where it eventually returns to its initial state. So the final state is the same as the initial state. So you can take a system through a series of changes and eventually you get to a final state where it was just like it was originally. What would be our delta E? 0, right? Because E final would be the same as E initial. We say energy is a state function. So delta E, in other words, if you were to add all the Q's and the W's for all the processes you went through, all of those Q's and W's are going to add up to 0. What would be their delta E for the surroundings? 0. And delta E for the universe? 0. Okay. Here's a question. A system goes through the following processes. It goes through step 1. Q for step 1 is 5 joules. That means 5 joules went into the system as heat, and the system did 8 joules of work. So W is negative 8 joules. Step 2, Q is 15 joules. W is 5 joules. So in step 2, the system did work. Lost 15 joules, gained 15 joules of heat, and it absorbed 5 joules of work. Okay? 5 joules of work was done on it. What's delta E for the overall process? 10? Okay. What do you do to get delta E? You just add up all the Q's and the W's. So what's 5 plus 15 plus, so that's 20, right? 25 plus negative 8. What would that be? 17 joules. Just add up all the Q's and the W's. Okay? What's delta E for the surroundings? Negative 17. Whatever the delta E is for the system, that would be the opposite for the surroundings. What's delta E for the universe? 0. So do you want one question on the test that asks for delta E of the universe? All right. A system goes through the following processes. Step 1, it went from state A to state B, and then step 2, it went back from state B to state A. Okay? So it goes through a series of processes from A to B, and then went back from B to A. Q for step 1 is 5 joules, W is negative 8. Okay? And step 2, Q is 15. What's delta E for the overall process? It goes from A to B and back to A. What's delta E? 0. Don't be tricked into just adding Q's and W's, okay? Because you're missing some information here. You're not told what the W is for this step. A lot of students get tricked by this type of question because they just remember delta E is Q plus W, so they see all bunch of Q's and W's, they just add them up. Okay, you have to realize if you're doing a cyclic process, delta E is 0. So in fact, if you add all of these Q's and W's, they're not going to add up to 0. That means there must be a missing information here. Okay, delta E of surroundings is how much? 0. Delta E of the universe? 0. What's W for step 2? Negative 12. Let's see. 5 plus negative 8 plus 15 plus W2 would be equal to 0. All of that should add up to 0, right? It's a cyclic process. So what would this be? 5 plus 15 is 20 minus 8, so that's 12 plus W2 is 0, so W2 is negative 12.0 joules. Okay?